Hi folks, welcome to my channel. So today I'm going to show you how to answer the last exam questions from Cambridge International Assessment. So it's paper 4-1 from May-June 2024. So let's begin with the first question. So in the first question, you have to describe solubility of hydroxides of group 2 elements and explain your answer. So you have to arrange them, you have to put them in that order of decreasing their solubility. So you should remember that solubility of hydroxides of group 2 decreases from top to bottom. And there are a few reasons for that. So you first need to state solubilities. So strontium hydroxide is in the bottom of group 2, so it's the most soluble one, and the least is magnesium hydroxide. So there are a few reasons for that. So first of all, you have to rely on enthalpy of solution. So according to its definition, it's the enthalpy change when 1 mole of substance is being dissolved in the sufficient amount of water. So enthalpy change of solution becoming less exothermic. So if you remember, the less exothermic the enthalpy change of any process, the more favorable that process and the more stable that product. In that case, it means that enthalpy change of solution of sodium of magnesium hydroxide becoming less exothermic. So most exothermic is for strontium hydroxide, meaning that the solution of it is more favorable. And you also can relate to enthalpy change of lattice and hydration because they are related to each other. So enthalpy change of hydration becoming less from strontium to magnesium, and lattice enthalpy is also decreasing, or you have to say becoming less exothermic. So it's not decreasing, so it's just less exothermic. So that's how you can answer this question. Also, you can relate to the ionic radius from top to bottom and distortion effect. So it's related to charge density. So from top to bottom, charge density decreases and hydroxide ions distorted less, meaning that the bonds are less stronger to break. Next question is related to the pH of these solutions. So you have to explain which solution is going to have the highest pH or lowest pH. So based on solubilities, uh, the more soluble the substance, more ions it produces. So strontium hydroxide is more soluble, is the most soluble, and it produces lots of hydroxide ions, which actually results in the highest pH of the solution. And you have to explain it like that. First, state which solution is having highest or lowest pH, and explain that more ions are produced when dissolved. All right, next part is related to calculations. So you have to find out the mass of barium hydroxide needed to make a solution of that pH 12.2 with that given volume. First of all, I suggest you to write what is given and what you have to come up with. So we have volume, just immediately convert it into decimeters cubed, dividing it by 1000. So it's just this. And write down the pH desired. Then I suggest you to write the expression of dissociation of the substance you have. So it's just barium hydroxide giving barium ions and hydroxide ions. And be careful with the ratio, you're going to use it later. So I suggest you, because when you do this, the solution comes just from nothing. It's hard to do this in your mind when you have lots of steps to. All right, then you have to find out the pH of pOH of solution, or find out the concentration of hydroxide ions. So you can do it just using that expression, just subtract pH from 14, or you can do it using ionic water product expression. Well, it's Kw equals to hydrogen ion concentration by hydroxide ion concentration. So anyways, you can find out OH ion concentration. From pOH is just 10 in power of negative pOH. And it's equal to this value, 0.01585 moles per decimeter cube. So be careful, it's just concentration, it's not amount of substance of hydroxide ions. So now we address to the equation of dissociation. As you see, the ratio of hydroxide ions and barium hydroxides is not the same. So it's 1 to 2, So it means that hydroxide, barium hydroxide uh, amounts is 2 times less than hydroxide ion concentration. So again, amounts of substance as well. So in order to find the moles of barium hydroxide, you just need to find the moles of OH ions and divide it by 2. So the amount of hydroxide ions is taken just multiplying concentration by volume. So volume is already given that we have to do. Concentration is found before and divided by 2 because the ratio is 1 to 2. So you'll have 1.98 by 10 in power of minus 3 moles. Then find the mass multiplying this number by this mass. So you're going to get 0.339 grams and write your answer in the provided space. All right, let's move on to the next part of the first question. So next part is related to solubility product expression. So you have some information about solubility of iron hydroxide at a given temperature. So you should remember that it's the amount of substance that can be dissolved in 1 liter, the maximum amount at given temperature. So it's depending from temperature. At higher temperatures, this value is going to increase. And you are asked to find out the solubility product for this substance. First, I suggest you to come up again with the reaction equation of this process. So iron hydroxide dissolves to iron ions and to hydroxide ions. And solubility product is just this expression. So you need to take concentrations of ions made in the power of their coefficients. So it's iron ions concentration multiplied by hydroxide ion concentration in square. So square comes from the coefficient. So it's the power now. Then you have to find out the solubility product of iron hydroxide. So according to our equation, iron ion concentration equals to the amount of iron hydroxide. So we're just simply taking uh, this number and putting it here. Then we have to multiply it by the concentration of hydroxide ions. But be careful here, concentration is 2 times greater than concentration of iron ions. So hydroxide ions 2 times greater. So we multiply it by that number. So 2 multiplied by concentration of hydroxide ions. And don't forget that you also have a power of 2 here. So just doing simple math, you're having 8.01 by 10 in the power of minus 16. Also, pay attention to the task. You have to include units. So units are coming from this expression. So it's concentration, which is measured by moles per decimeter cube. And here it's in a square. So doing simple math, you're having moles in power of 3 multiplied by decimeter in power of minus 9. So that's it.